Hi, hello everyone. Welcome to the next series into our AWS journey. Today we're going to talk about the VPC. Hopefully you remember from the last time how these services are grouped together. So we are focusing on VPC, which is grouped under the networking. On the Amazon Management Console, you can say the VPC says it's an isolated cloud resources. So let's walk through a quick presentation, and as usual, we'll go through a lab. VPC is a pretty kind of a nice topic. So, I've decided to do multiple labs just to walk you through different scenarios, probably. So, let's go ahead and start the presentation and then we'll focus on our hands-on lab. Okay, hopefully you guys are able to see. So Amazon Virtual Private Cloud, or VPC in short, in simple terms, think of VPC just as a virtual data center. Yeah, it's pretty much that's all in the cloud, where basically that lets you provision a logically isolated section of AWS cloud where you can launch AWS resources. So when we say resources, like EC2 instances or your load balancer, and there are other things in a virtual network that you define. So the key here to pay attention is virtual network that you are defining. So VPC allows you to define your own virtual network. And the great thing is you have complete control over your virtual network environment. So what that means, you can select your own IP, your own private IP error scheme, number of subnet and their type. Well, the meaning by the type, like you can have a public facing subnet where you can host your web servers, or public facing applications where everybody can access those. Or you can have a private subnet, something like where you can host your database, which are consumed by, let's say, those web applications, web servers, or maybe some other applications or server that you don't want to be exposed on the internet. You can configure the routing tables the way you want. Now you have, let's say, imagine we created two subnet, one public facing and one private facing. So the public facing will have access to the internet by default with the help of Amazon's internet gateway. But on the other hand, the private subnet, they don't have any access to the internet. But let's say you need to update those servers, or you need to go out from those servers. So you can set up something like a NAT instance within one of your public facing or within your public subnet, and you can route your all private network if they wants to go to internet via that NAT instance. So you're just not getting the virtual network, but if you see, you are increasing your security also. So basically you can leverage multiple layers of security, like we had used in the past security groups, where you can say who can access, what are the ports that I want to expose. Let's say you want to allow access to port 80. Do I want to allow port access to the port 443, 22, and so on. And like as I just discussed, you can configure a NAT instance, so which is nothing again an EC2 instance running NAT functionality. So your non-public instances, and let's say in our case a database server, can reach outside via NAT. So that way we are not exposing the database server at the same time. That database server can go outside if it needs to download certain patches. And the great thing, you can create a VPN connection between your corporate and your VPC and leverage the AWS cloud resources as an extension. So you can just create a VPN connection. You can do a hardware or software, and where you can connect your existing environment to your newly created VPC and make use of those resources. So hopefully that gives you a good idea. And again, there is a good information out there on Amazon's website. So you can go and look on Amazon's website on more details about the VPC. This is a very basic definition what a VPC does. And there are many more cases. I'll walk you through when we do lab. There are a few things like I touched on the route tables. So you can create your own custom route table. There is a default route table. So the default means if you don't create that, something is used, which has access to the internet. If you delete that by any chance or by mistake, the only way to recover is by calling the Amazon. So it's better not to delete that or not touch if you are planning to create your own. So I'll walk you through some of those things when we do a hands-on lab. But hopefully you get an idea about the VPC. VPC is just all about, the virtual network that you can define in the your cloud, which acts as, kind of a virtual data center. So in today's lab, this will be our topology that we will be working with. So in this topology, the VPC, so we will be using a VPC CIDR. Hopefully you guys are familiar with the CIDR IP addressing scheme. So we'll use a 10 subnet, with the 16, so in the B class here with the 16. So if you look here that in this VPC, there are two availability zones that we are creating. I'm calling them availability zone A and availability zone B. And if you look within each availability zone, we are creating two subnets. There is a public subnet, there is a private subnet. So within availability zone A, we'll be creating a public subnet, and public subnet 1, in this case I'm calling, and the subnet I'll be using is 10.0.0/24, where we'll run two servers. One will run a public web server, and another will go ahead and run a NAT server. Within the private subnet, or within availability zone A, we'll be using the subnet 10.0.10/24, and we'll go ahead and run a Microsoft SQL Server, just to show some of the database functionality, but will not be working with the MS SQL in any way. Within availability zone, we have again similarly created another public subnet and a private subnet. The public subnet is 10.0/24. Within that, we'll create another Windows server, and we'll allow RDP functionality on that one. So I will show you that, if we don't have to expose this database server to the outside. If you want to connect, we can run another Windows instance, secure instance, and then we can connect to that instance over the internet. And once we are inside that, then we can connect to our rest of the Windows server or probably some other server. In the private subnet, I'll not be creating anything, but you get the idea. It's the same thing. You can have multiple servers over here. So this will be the topology that will be working within this lab. Hopefully you get an idea. We'll come back to this topology as we progress throughout this lab. And I've already logged on. I have provisioned some of the things just to save some of our time. Like I went ahead and created the NAT instance. Hopefully you get an idea. Like in the last lab, I showed you how to create a web server. So pretty much there are Amazon AMIs out there. You can use those AMIs to spin up your instances. So in this lab, we'll cover the few of these things. I'll walk you through a creation of a basic Amazon VPC. Then we'll launch a web server. We'll go ahead and assign elastic IP addresses. I haven't talked about elastic IP addresses, but once we on that section, I'll give you some details about the elastic IP addresses. We'll go ahead and launch a backend Microsoft SQL Server. We'll go ahead and create some more subnets manually, and then we'll launch that RDP host on the public facing side of the subnet, and then we'll connect to that server. So hopefully, once this lab is done, you will have a good understanding about the AWS and some of the other things. So let's go ahead and get started. So under networking, we'll go ahead and click on VPC. But before we click on VPC, let me just show you something. If you go under compute EC2, there is nothing running as of right now. There is one security group, one key pair, so just keep in mind. And we'll go back to the networking. We'll go back to the VPC section over here. So if you look, it says there is already one VPC. There are 3 subnets here. There's one route table. So let me just show you something pretty quick. The route table that we discussed. Let's go ahead and click on this route table, and it says the default VPC. So that's where this is something that once you create your Amazon account or your AWS account, that's what gets a provision. So if by any chance if you delete this one, the only way to recover is by calling Amazon Web Services support. So just keep something in mind. There are some nets already there, which are on again our existing subnet, which is internet facing. They are part of the default VPC. They are in two different availability zones, 2A, 2B, and 2C. So let's go back to our VPC dashboard. We'll go ahead and start with the wizard. So I'll simply go ahead and click on Start on VPC Wizard just to get started on this section. I'm sorry, I just clicked on the wrong link. So let's go ahead and click on Start a VPC Wizard. So once you start the VPC Wizard, there are different scenarios already presented by this wizard. It says a VPC with a single public subnet, VPC with public and private subnet, VPC with public and private subnet and hardware VPN access, VPC with a private subnet only and hardware VPN access. So you get the idea. So in our case, we'll be building a VPC with both public and private subnets. So I'll go ahead and click that. So this is similar to like our diagram where we have your Amazon cloud, we'll have a public subnet, and we'll have a private subnet. So just simply go ahead and click select over here. Once the wizard start, you can see VPC. Let me go ahead and zoom a little bit so it's a little visible to you guys. Hopefully it's better visibility. So if you recall the lab diagram, so this CIDR block that we are using here is 10.0.0.16. We can go ahead and give it a name to our we can supply a VPC subnet. So for the public subnet, 10.0.0/24, that was the subnet that we had, if you recall. 10.0.0/24, that's what something we are using. So we are keeping, this is our first public subnet under the availability zone. So let's go ahead and I'm going to keep this in the US West 2A, and we call that as a public subnet. Let me just append one here, and a private subnet, and if you recall, this is 10.0.10/24. So this is my first private subnet, and again under the availability zone. And if you recall, we need to keep them both in the same availability zone. So under availability zone, I'll go ahead and select same 2A, just append one here just to be sure. Once that is done, now with the private subnet, you can add one or more subnet after VPC creates. So I'll walk you through how to do that. Specify the details of your NAT gateway. So if you see here, we can configure user NAT instant. So basically, what this is telling that for your private, we can just go ahead and simply say, okay, hey, if these private subnet wants to go to the internet, please make use of a NAT router. So we can go ahead and simply click use a NAT instance. So I'll just show you what this is going to create. So in the instance type, this is the type of the instance. Again, we'll talk more about details of this different type of instance when we do the EC2 lab. But for the time being, the EC2 instance or the VM that I'll be creating, that will have the type of T2 micro. This is my SSH key, so I'll go ahead and select my SSH key. We are enabling the host name hardware tenancies default, or we can have a dedicated. Dedicated will be something costly, so that means you're asking Amazon to host your things on dedicated hardware versus the shared hardware. But for our purpose, our default serves well. Just to go back one more time, IP server block is the main your VPC. In this case is 10.0.0.16. This is our first public subnet, 10.0.0/24. This is our private subnet. They both are into same availability zone. So in our case, the availability zone that we have picked is US West 2A. That's our public subnet 1. This is our private subnet 1, 10.0.10/24. We are making use of the NAT instance. So we went ahead and selected NAT instance. That means the private subnet you want to talk outside will make use of this NAT instance. And the type of that in that instance, we are saying T2 micro. And once everything is done, just simply go ahead and click on create a VPC. So you can see it started doing a few things. So give it a couple of minutes, and once that is done, we'll go back and we'll explore some of these options. And just to reiterate, guys, the VPC that we just built right now, everything is in a single availability zone right now, as of right now. And we just created an ad server for our outbound requests. So it'll take a few minutes. So let's go back and click OK here while it's doing something. We go back and let's go back to EC2. I just wanted to show you something pretty quick here. So now it says there are one running instance. If you click on, sorry, let's go back to dashboard. It says there is one running instance, there is one elastic IP address. So let's go back to your running instance. So if you click on running instance, this has a public IP address. So anytime when you spin up an instance, Amazon automatically assigns a public DNS and public IP address unless you say that it's a private instance. But in this case, we went ahead and configured elastic IP. So the elastic IP is think of an static IP, which is something assigned to you by Amazon. So you can use this IP. That means if you shut this instance down or you reboot this instance, you will still have the same static IP. So you can have only 5 static elastic IPs per availability zone. So you go back to the elastic IPs and you can see this is your elastic IP and it's assigned to what instance. Let's say if this NAT instance dies or you want to assign to a different NAT server because you want a bigger capacity or something, you can simply disassociate and associate to a different instance. Let's go back to the instance and you can see it started to spin up a NAT server with the T2 type micro. It's already running. Status is just initializing. Hopefully you recall from some of our previous labs. And if you see the private IP address is 10.0.0.10 on this one particular host. So 10.0.0.10, and if you recall 10.0.0.10, so it belongs to this public IP. That's there. This is the internal IP address, and the IP address was assigned from our subnet that we just created. So hopefully you get an idea that with the VPC we just created, we created 2 subnets, and within our public subnet we went ahead and created our first EC2 instance, which is using the IP from this public subnet. Now let's go back while this is still running. So we'll go ahead and launch a web server like as we just saw in the diagram. So now let's go ahead and launch a public web server within our public subnet. So it's pretty easy again, like we have done. So you go back to the instance and just simply go ahead and click on launch instance. We'll go ahead and select the Linux again here. So we'll go with the Amazon AMI Linux. Just simply go ahead and click next. I'm keeping it at T2 micro. Configuration details. So if you look on the configuration detail, on the configuration details page, that's what something we need to pay attention here. Number of instances, we just want 1. But if you see the network here, go ahead and click on drop down. So we have a default VPC and we have a newly created VPC. We didn't assign a name, but we could give a good name. So we want this instance to be within our VPC. So go ahead and click that VPC. Once you click that VPC, it says, okay, here there are 2 subnets. So within which subnet you want this subnet to reside. So we want this instance to reside in our public subnet. So go ahead and select your public subnet. Once that is done, there is, it says auto sign public IP used in the subnet settings are by default disabled. So we'll go ahead and say enable that. We want to assign a public IP address to the subnet. So that means once the subnet, once this instance is up and running, AWS will go ahead and assign a public IP address so you can access this instance via that public IP address. I'm not changing any of these details for the time being. Again, we can just leave it. You can see here, it's going to create an interface. It's calling ETH0, and it's assigning a primary IP address being auto-assigned. If you want to assign a static IP address, you can just simply go ahead and enter that over here. And like as we did last time, we'll bootstrap some of the things when we boot the server. So let's go ahead and make sure, we'll go ahead and install HTTPD and then simply we'll go ahead and start that our Apache server. So just simply click on storage. We're not making any change here. I can go ahead and very well give it a name here. So let's call it a web server 1. Now on the security page, this is what we did last time. So let's call it our web server. So we are allowing SSH from anywhere because of the web server, we want people to connect. So I'll go ahead and enable HTTP as well as HTTPS access. So once that is done, just simply click on review. It shows you some of the detail. Just simply go ahead and click on launch. Okay, this is my SSH key, so I'm good. I'll just simply go ahead and click on launch. So it started to launch this instance. That will take a while. And if you want to see that this is the instance NA ID, so go ahead and click on view instance. It's right now it's pending. So let's go ahead and click on this one just to see some of its detail. And you see it's under US West 2A. There was a private IP address was assigned 10.0.0.37 from our public subnet 1 subnet. And these are the public IP address assigned by the Amazon. So if you want to access the server, you would either use this DNS hostname or the public IP address. So we'll give it a few minutes and okay, so the instance is up and running. Let's say if we can connect to the web server over this IP address. Okay, not right now. The server is still going through. So let's see if we can do an SSH. If not, then we need to wait for some time before it's fully up and running. So I'm just connecting to that server on a different screen. Give me a second, I'll show my screen. Okay, so I was able to do that server. And if you see the IP address is 10.0.0.37. That was the IP address that we saw here. So right now it's running, it's initializing. Let's see if the Apache started. Okay, good. So the Apache server has started to respond on the server. So now you can create some of your websites or anything, and hopefully get an idea now that we have an instance which is running within our public subnet or within our own VPC. So we have a public web server as well as we have a net server. And when we created this VPC, we told the private subnet to make use of the net server to go out. Hopefully you got some good ideas. So what we have done so far in this lab, so we had created so far a VPC with the help of Wizard, and we created these two subnet within one availability zone. We went ahead, created our first public web server as well as a net server. Now we'll go ahead and launch this MS SQL Server within our private subnet. So let's go ahead and do that. So it's again very easy. We'll go back to the EC2 console. We are already on the EC2. We'll just simply go ahead and say launch instance. And this is we are launching the Windows 2008. So let me select Windows 2008, and we plan to launch an SQL Server. So I'll go ahead and select it. Microsoft Windows Server 2008 R2 with SQL Server Web, which is here. And once that is done, just simply go ahead and click Next. For our purpose, I'm going to change it to M3 large, so we can quickly spin up and we'll have some services. So in this case, I'm using an M3 large instance for my database server. If you're planning to do production, size accordingly. Now go ahead and click on the instance again. On the network, make sure you are selecting our VPC, not the default VPC. That's what we want to make use of. And this is our SQL Server, and looking at the diagram, it needs to go under our private subnet 10.0.10. So select the private subnet here 10.0.10. And again, we don't want to assign any public IP address because this is within our private facing subnet, private subnet. And I'm not making change to any of the settings, but if you recall, I mentioned last time, there's the interface, and right now it says auto assign. I'm going to go ahead and assign a static IP address to my database server. So in this case, I'll use 10.0.1.99. And if you see 10.0.1.99 belongs to this subnet, which is our private subnet 1. Once done, just simply, I'm not doing any bootstrap on any on this one, so just simply click on add storage. We're not making any change over here. Just simply go ahead and click tag. So just give it a name. I'm just calling it SQL Server on the security group. So this is something interesting that we need to pay attention here. So by default, so I'm going to call it a SQL Server. SQL Server security group, and by default it says, okay, hey, you can do an RDP from anywhere, and the MS SQL port can be accessed from anywhere. So right now we are exposing this SQL Server RDP from anywhere, and same thing, anyone can connect to the MS SQL. We'll go ahead and change the security settings once we have the server up and running. We'll make sure that people can only access the MySQL within this VPC, and if they want to do an RDP, they need to come via a public facing subnet, and only then they can connect to this private subnet, not directly. So for the time being, I'm just leaving these settings. So we'll be making changes to these settings later on. So just simply go ahead and click on review and launch. Check the settings, everything looks good. Just go ahead and click on launch. I have my key pair, and just simply click on launch instance. It will take a while. And the instance will be up and running. Let's go ahead and click on view instance. So now you can see there are 3 instances, and this is something our first part. So we have public web server, a NAT server within the public NAT. Public subnet, we just created MS SQL Server within our private subnet. And that's the IP address for the Windows Server. 10.0.1.99, that was the IP address assigned, but you can see there are no public DNS, there are no public IP, there are no elastic IPs assigned to this one. And this is again within the availability zone 2A. So hopefully you got the idea. Now let's go back to the services, and we go back to the VPC again. And now we'll go ahead and create, we need to create another public subnet and another private subnet into another availability zone, as just we discussed earlier. So now we are back to the VPC dashboard. Now go back to the subnets, and if you click on subnets, let's expand it a little bit. you would see that we have our existing private subnet and public subnet. This is the server. They are both are into the availability zone 2A. So we'll be creating two more subnet, one public and private, and we'll be configuring them in the different availability zones, maybe 2B or 2C, depending on that one. So it's pretty easy. Just go ahead and click on create subnet. So once you on create subnet page, go ahead and give it a name. Let's call it public subnet number 2. By default, okay, we have our availability zone, so I'm going to configure them in 2A. And the CIDR block for this is 10.0.10.0/24. If you recall, 10.0.10.0/24, 10.0.10.0/24. Just simply go ahead and click create. Once that's done, we'll go ahead and create our, so you can see over here, now go ahead and create our another private subnet. So we'll call it private subnet number 2, again on with another 2B. So it's 10.0.11.0/24. Just simply go ahead and click create yes. Okay, so let's arrange them probably. Okay, they are already arranged. So let's have a look here on our first public subnet that we had created. So if you click on first public subnet, which is 10.0.0/24, and these are the different summaries. It says there's the subnet ID, CIDR address, VPC that it belongs to, the route table, and this is narrow access control list in this case. So let's go to the route table. And if you look at the route table, it says, okay, hey, if any traffic that wants to talk to the 10.0.0 and goes to the target being local, so that means within the VPC, the traffic remains local. They are not doing anything outside or anything. But if they wants to go anything outside, they will make use of this IGW, which is Amazon's Internet Gateway. So there is nothing. It just says, okay, hey, this particular VPC is connected to this Amazon Internet and Gateway. So we can go back to the route table. Let's go back to the subnets again. Let's rearrange. This is our public subnet. And now let's go ahead and click on the network access control list here. And if you look on the network access control list, this is the network access control list, which is being allowed, right, created and configured right now. And the rule says that, so these are the inbound and outbound. For inbound, we are saying all sources. So we are allowing everything, and same thing we are allowing for the outside one. Now let's look at the 10.0.1. This is our private subnet. So if you look at the private subnet route table, it says, okay, hey, for this one, if it wants to run 10.0.0, it remains local, but if it needs to go outside to make use of this particular target, and this particular target is nothing but it points back to our NAT instance. So that means if the traffic needs to go to the internet, I will send that traffic to our NAT instance. So if you see here, it says F84. So if you go back to services, and if you go back to EC2, and let's go back to the instances, and let's click on this one. So you can see the ID being F84. So you get the idea here that anytime if this private subnet needs to go to the internet, they will send the traffic to that particular NAT instance. Now let's click on the route table just to see there are different route tables. So you see, there are two different route tables being created here. One says there is a main, there are zero subnets associated. It's not main, there is a one subnet associated. So we can click on one of the route table just to see some more details. Again, these are the names. These are different routes. Again, for this one, anything would go to the internet. Are there any subnet associated? Yeah, there is one subnet associated, which is our public facing 10.0/24. And if you recall, this is the subnet, internet. I'll come back to this one. Just pay attention. There is one subnet which is connected to this particular route table, and this route table says, okay, hey, they and this route tables, anything remains, within 10, it remains local, but rest it sends to the internet gateway. Let's look at the other route table, and if you see here, if you recall, this one again, 10 traffic remains local, but anything needs to go to the net instance. And if you click on the subnet associations here, there are no subnet associated as of right now here. Okay, so now let's go back to the public subnet. And if you go back to our diagram, we have two public subnet. One is 10.0/24, another one 10.0/24. So right now, and this route table has a default gateway of the internet. That's what we want. So right now, only our first subnet, the public subnet, has access to the internet. We need to do the same thing with our 10.0/24. So we need to associate this subnet to this route table, and it's pretty easy. Just simply go ahead and click on edit and select our 10.0/24. Once that is done, just simply go ahead and click save here. And once that is done, you can see that now both of our public subnet are connected to this route table. That means they have a reachability directly to the internet. We need to do the same thing with our private subnet now. Let's go back to the so we can go ahead and simply associate. Let me go back to the subnet here pretty quick, and let's click back here and have a look on the public subnet. So let's go and deselect. And if you look at the route table now, that for this, anything within 10 remains local, but then the default gateway is now to the internet. Look at our private subnet now. The private subnet, again, 10 is local. Anything will go to the NAT instance. Now let's verify is this the same case for our private subnet 2 or not. So yeah, that's the case. So if anything within local remains within the 10 thing remains local. If it needs to go outside, we'll make use of the internet, our NAT instance. So hopefully you get the idea behind these different routing tables here. So once this is done, what we just did, we created our, if you go back to your VPC or you go back to the subnets maybe, and let's arrange them. So we have a public subnet and a private subnet in availability zone 2A. We have another public subnet and private subnet in the availability zone 2B. So this is the first section that we done. We just went ahead and created these two more subnets right now. and we connected the subnet to our route table, which is access to the internet or the internet gateway. Now let's go ahead and launch the Windows. Let's go ahead and launch this Windows server that will use as a public facing RDP, and then we'll go ahead and tighten the security for the server. So pretty easy. Again, we'll go back to the services. Let's go back to the EC2. Let's launch an instance. Let's find 2008. We'll use just a base server. We don't need anything special here. We'll stick with T2 Micro for the time being. Configuration, again, we want this to be in our own VPC. And now we want this into our second public subnet, which is 10.0.10/24. I'm not changing any of those other settings. And we are saying, okay, auto assign an IP address. Give me a second, guys. Okay, on the network side, we get subnet. I went ahead and selected the subnet here. Okay, and once that is done, just simply go ahead and click on add storage. We're not doing anything. Just call that our public RDP host or something, whatever you want to call. Now let's time to configure our security group here. We don't want anything, so I'll call it pub RDP server. We are just enabling the RDP, no any other role. So we'll go ahead and simply review and launch, and then we'll just simply level launch. Okay, I have my access key. Just simply go ahead and launch this instance. Give it a few minutes. Once the instance is up and running, I will be good to go. Now, while this instance is launching, now we have our public-facing RDP server or Windows box. Now we can go ahead and change the settings on our SQL Server. So it's pretty easy, and if you see the SQL Server, the security group that we assigned was the SQL Server. So you can click on SQL Server here, or you can go under security groups, and then you can make the changes from here. So let's go ahead and select our SQL Server. And if you will see the details, there are inbound rules and there are outbound rules. Outbound, we are allowing and everything. On the inbound, these are the different rules. Before we do anything, let's go ahead and make a note of. Let's go back to the instances and this public RDP. I need you to make a note of the group ID. Let's go back here. Okay, sorry. Yeah, so this is the group ID. Why do we need this group ID? I'll tell you. So basically what we are saying that our public RDP server can connect to the internal SQL server. So we are restricting based on the group ID. So I'll just go ahead and copy this ID. So save somewhere here. And once that is done, now let's go back to our SQL server and we'll go ahead and click on edit here. Once that is done, on the inbound rules, so right now let's remove the existing public RDP. Let's go ahead and click a new rule. We'll call it RDP port now. And in the custom IP, we're not going to enter an IP. We're going to enter our group ID for our public RDP server security group, and you can see that over here too. So you can just simply, so what that means, we are saying if only this server can do an RDP to this particular host. Hope you get the idea here. So now just simply go ahead and click save. And again, we can make the changes to same thing. That's okay. Who can access maybe in our public facing web server is the one only who can connect to the SQL server. So you can change, make changes to all of these things depending on your use case. I'll go ahead and simply click here, save. Once that is done, let's go back to our instances and look at the status of our public RDP host is still initializing. Now, if you see that this host got an IP address 10.0.10.21, which is from our second public subnet 2, but there is no real public DNS record or public IP. That means you cannot connect from outside. So now how do we do that? Again, I said we don't want to lose the DNS IP address, public IP address every time, we don't want a new one every time if the instance reboots. So we'll go ahead and get a new elastic IP address. So click on elastic IP address and just simply click on allocate a new IP address. We'll get a new IP address and click close, and you can see this is our elastic public IP address. Now click on action and associate this address, and you can look. So we want to associate this with our public RDP host. Keep rest of the things same. Just click on associate, and once that is done, we get to go now. So what we just did here, if you look back our diagram, we just created this public facing RDP server. And on this public facing RDP server, if you look at the security group rule here, we are just allowing RDP. So that means from outside, you can RDP to this host. And if you go back to our existing SQL server, look at this security group. We just told that only this particular security group can do RDP to that particular host. So within the security group is utilized by only one host, which is our public facing. So that means this is the only host which can do an RDP to this SQL server. We haven't done any configuration setting or security for our MS SQL port, which is still open to anyone. But again, we can restrict that to probably to this web server or maybe some other server. So yeah, you can go ahead and make those changes. Let me just show you now how we can connect to the server. So let's go back to the instances. Let's go back to the public RDP host, and let me make a note of this one, and I'll go ahead and do an RDP. So give me a second, I'll do an RDP on a different screen. And I do have the password, so give me a second. Let me look at my Windows RDP host password, and let's click OK. Sorry guys, I forgot to make a note of the password. So how do you get a Windows RDP instance password? It's pretty easy. Go back to your host, And under the actions menu, there's an option that says get a Windows password. So you need to supply your key here. So let me go ahead and get choose the key here. So give me a second, I'll come back to the screen. So I'm just gonna let me give me a minute, guys. I'll go ahead and get the password. And as you can see that I'm connected to this public IP address 147, and if you recall, this was our public IP address 147. So you can see I'm connected to this particular host, and that's trying to launch things over there. Okay, and you can see this is the private IPS 10.0.10.21, 10.0.10.21. From this, we can do an RDP to this host 10.0.199. So we need to again get the password for this this Windows box. So let me go ahead and get the password for this Windows box also. Again, as I showed, you just right click and do a get Windows password. So give me a second, I'm going to get that password. Okay, you will get something like this. You decode. So that's the IP address for that server and that username, and just the password. So simply go ahead and supply the IP address. So 10.0.1.99 if you need to confirm. 10.0.1.99. Just simply go ahead and click connect and enter the username. Administrator, I copy my password, and you can go ahead and click to that one. And as you can see, we are connected to 10.0.1.99, which is the IP address for our SQL Server, which is inside our private subnet. So only this host can connect to that particular SQL Server. So now you see that we are coming over the internet. We have our RDP host, and we are connected to the MS SQL Server. So that's all pretty much, guys. I think hopefully you get the idea that what is VPC, how you create your own VPC, how you can create a different multiple subnets, how can you restrict in who can talk to what based on the different routing tables, and some of the other things. So again, you go into services, VPC. You can see we have 2 VPC, there are 7 subnets, there are 3 route tables, and so many different things. And if you click on these subnets, and you can see these 2 subnets are spread across 2 availability zones. So that's all pretty much. Hopefully you got a good idea about a VPC and this hands-on lab. Maybe we will do one more lab on the VPC. We'll build them in maybe a little bit more complex topology. But hopefully you get the idea, how do you create a different subnet, a route table, how you create and associate your subnet to a particular route table, elastic IPs, some of the NAT gateways, and everything. So that's all pretty much for this session. And thank you so much. I will see you next time in another lab and another session. Thanks. Bye-bye.